Today we're going to be talking about the scientific method. The scientific method is used by professional scientists to answer pretty big questions about the world, but it can also be used by anyone really to explore observations they have about the world and then find answers to those questions using an experimentation process. So today we're going to be starting to understand what that process is. We'll be looking at the different steps involved and practicing identifying those steps and designing our own experiments. And we'll continue this in class as well. But this presentation should help you just get a basic understanding of what are the steps involved and how can we design our own experiments. So while the scientific method can be used by scientists who are working in a lab every day as a part of their job to answer pretty big, complicated questions in the world, such as like the scientists trying to discover cures for Ebola or other epidemic diseases, you can also use the scientific method to answer almost any why question you might have. For example, if you came down the stairs in the morning to make your breakfast and you put some bread in the toaster, turned it on, and you found your bread wasn't toasting, you might say, wow, why is this not toasting? Which is the first part of the scientific method. You make an observation, my bread's not toasting, and it leads you to ask a question, which is, why isn't this toasting? Some of you may have even done this recently. Maybe you thought, maybe the outlet isn't working, and you switch the outlet that the toaster is plugged into. That would be you developing a hypothesis about why it isn't toasting and then trying another method. And maybe when you plug the toaster into a new outlet, it does work, and then you have a solution. Maybe it doesn't work, and then you have to try another hypothesis. So you can use the scientific method in any day questions that you might have. Why do fireflies only come out in the summer months? You could develop an experimentation about that question. Why is my mom so grumpy on certain mornings? That would be based on observation. You notice that some days your mom's grumpy, some days she isn't. And you could form a hypothesis. Maybe it's the morning she has coffee, maybe it's not. And you could do a test to figure that out. So it's a really important process that you all are probably already using in your everyday life. So we're going to practice this scientific method process as a group. And I'm just going to start us off with a story, and you can follow along. I find that I'm always late to school. I try my hardest to leave my house at 7:45 every day so I get to school at 8, but somehow I'm still late. This makes me wonder, why am I always late? It could be the route I'm taking to work, when I drive that route on a weekend, when I have to be at the school for cross-country practice. I always seem to make it on time, but on weekdays there's always a lot of traffic on this route. To figure out which route is fastest, I decide to try a different route to school each day for a week. I leave my house at 7:45 every day and start my timer at that time. I take a different route Monday, Tuesday, Wednesday, Thursday, and Friday, and I record the time it takes to get to school. By the end of the week, I figure out the route I'm taking is the slowest, in fact. So now we're going to use the story I just shared to think about the steps of the scientific method and think through how I solved that problem using the scientific method. So in your science notebook, I'd like you to answer the following questions about my experiment, and we're going to go through them in the next couple slides. The first question is, what was my observation? The next step of the scientific method is to ask a question. What question did I come up with from my observation? Next, you come up with a hypothesis. So you're going to think about what my hypothesis was. And then you're going to test that hypothesis with an experiment. And we're going to think through how I tested that hypothesis. What was I testing? What was I measuring? What parts of the question did I keep the same? And then we're going to look at the conclusion I draw. So we'll go a little more in depth into each of these pieces in the next couple slides. So we're going to start by thinking about that first question or first step of the scientific method, which is make an observation. I want you to look through, I have the story listed below on this slide. I want you to look through and figure out what my observation was. So I'll give you a minute to do that, and I want you to write it down in your notebook. So hopefully what you decided was my observation was that I noticed, even though I'm trying really hard to leave at the right time to get me to school in time, I'm always late for some reason. So that was the first observation I made. Hopefully you picked that out. If not, that's okay, because we're just practicing together and you'll have a few other chances to practice this. So don't worry if you didn't get it right away. The next step in our process is to ask a question. So you're going to take that observation you made and develop a question. Again, I'd like you to take a minute and write down in your notebook what my question was. If you wrote down that the question was, why am I always late? You are correct. And it's pretty easy to find in this example. It may get harder in other examples we look at, but yeah, from my observation, I wondered, why am I late? Next, you're going to come up with a hypothesis. So we often call a hypothesis an educated guess. So you don't usually want to pull your hypothesis, which is what you think might be the answer to your question. So again, the hypothesis is an educated guess about what you think might be the answer to your question. You don't want to just pull it out of thin air. Sometimes scientists have to, but usually there's a lot of information you have that can help you form that guess. So I'm going to give you a minute to look at my story and think what my hypothesis was. So in this example, the hypothesis I came up to was that it could be the route I'm taking to work. And so again, the hypothesis is your guess on the answer to the question based on background information you have. So in this case, the information I based my hypothesis on was the fact that when I drive to work on the weekends, where there isn't a lot of traffic, I don't have a problem. But on the weekdays when there's a lot of traffic, I do end up being late. So that's sort of what informed my hypothesis, which is a really important aspect of the scientific method. You want to make sure there's some research, some data, some observations you've already made that back up your guess or your hypothesis. Next, we're going to test that hypothesis we made, that educated guess, with an experiment. And this is the trickier part, is developing the experiment that you're going to do to test your hypothesis. But I want you to take a minute and, in my story, figure out what my test was. What did I do to test my question? So in this case, the test I did was that I drove a different route to school each day, and I timed myself each day. And so I was timing those different routes and using that to figure out, is it the route that I'm taking to work that's making me late? Another really important part of the scientific method that kind of falls under our testing the hypothesis step is developing a couple variables. We have an independent variable is the thing we're testing. So I'm going to give you a second to identify that in the story. And the independent variable is really important because we wouldn't want to be testing something that doesn't relate to our hypothesis, right? I wouldn't want to test the temperature in the car I'm driving, or the pollutants coming out of my car, because those don't relate to the question I'm asking at all. The other important variable is the dependent variable, what I'm measuring. Again, also really important that it relates to your question. So in this case, what am I measuring to answer my question? And finally, what stays the same in the experiment is called our constants. So if we change too many variables, if I were to change everything about my experiment each time I did it, it would affect my results. So you have to keep some things the same. So I really want you to think about, in this story, what was I testing? What was I measuring? And what stayed the same throughout the whole experiment? So if you need to pause the video and take a minute to write those down, you can do that now. All right, so hopefully you were able to figure out that the thing I was testing was a different route that I'm taking to school each day. So I was testing the routes that could get me to school on time or not. So that's my independent variable. And the dependent variable, the thing I'm measuring, was the time it took to drive to school. So that amount of time was what I was measuring. In terms of what stayed the same in my experiment, this wasn't as clear in the story, so hopefully you did a little stretching in your thinking to figure out that I drove the same car to school each day. And so that should have stayed the same. And I left at the same time every day to make sure that I didn't confuse my results with the route versus the time I leave. So if I had changed the time I left every day, that might have affected my results. Maybe the traffic is worse at 7:55. So that would have been a different experiment, but in this experiment, I kept it the same. And if you didn't get those this time, that's okay. We're going to keep practicing those things. And finally, we're going to draw a conclusion from our test. So hopefully you're looking at my story and realizing that my conclusion was the route I'm taking to school is in fact the slowest. And if the route I'm taking is the slowest, then that means it is the route I'm taking to school that is making me late. And if I found a faster route, then that would get me to school on time. So hopefully you were able to find that conclusion as well, and write that down in your notebook. The last thing I want to mention before having you all do your own practice in identifying the steps of the scientific method, the last thing I want to mention is that oftentimes our scientific method is a linear process that goes from step to step, like we just did. You ask a question, you make an observation that leads you to that question, you create a hypothesis, you test that hypothesis, and then you get a conclusion. That happens, but sometimes our steps have to be repeated or visited, and it becomes not quite a linear process. So you can see on this chart here, sometimes your test doesn't work, or you don't quite get the results you thought you would, and you have to ask a new question. So we will do a lot of practices where it is a linear process, but just know that sometimes it's not, and sometimes you have to go back to another step. You have to revisit a step or redo a step. So it's important to keep that in mind. So now that we've gone through the steps together of the scientific method, I want you to practice doing it on your own. So again, in your science notebook, I'm going to have you read the following scenario about some things going on in a local park. And then I want you to answer the questions below in terms of what observations are being made, what question, what hypothesis do you have, and how will you test that hypothesis. So you should record all that in your science notebook. So just to wrap up, to class tomorrow, you should bring your notes on the scientific method as well as your answers to those final questions. And there's a picture of my dog with some crazy bedhead. So I will see you all tomorrow in class. Don't forget to bring those things with you. Thank you.